The next advanced pointer topic that we're going to look at is called the null pointer. What is the null pointer? Well, it's usually a hash define. In fact, it is a hash define. You'll find it in stdlib.h, and it's used quite frequently by functions in the standard C library, such as malloc and fopen and so forth. These functions use the null pointer. In fact, they return to you a value of null. In other words, they return to you a pointer, and that pointer happens to be the null pointer if there's some error condition, such as malloc could not set aside that amount of memory, or fopen could not open the file. They'll give you back a null. Null is simply taken to mean this is an invalid pointer or it's some sort of error condition. So if you need to test whether things like malloc or fopen failed or succeeded, you can compare their return value to null. Now, in case you're wondering what null actually is, its definition is as follows. It's usually written like so. It's just 0, the number 0, cast to be a pointer to anything. In other words, it's the 0 memory address, or that address that represents the right at the beginning of memory, something that we will never ever refer to legally in a program. It's vitally important to check the return values of things like malloc and fopen and any other program that you design yourself that uses null to see if the pointer that you've got stored, where you store the return values of those functions, is actually equal to null or not. If you don't test, and you just go ahead and assume that fopen worked or malloc worked, then you can actually try and write data to the 0 memory address, which will simply crash your program, almost guaranteed. This is known as dereferencing a null pointer, and it's one of the most common types of errors that you can have in C. It usually means that somebody's been lazy and they haven't bothered to test whether a pointer was null or not. When some people see that the null pointer is actually equal to 0, they try and write expressions like this. If not malloc, they might say malloc 10, I want 10 bytes, and they might test if not malloc. Now what does that mean? Well, it means if malloc is equal to 0, or put more correctly, if malloc returned a value of null. So I would think it would be much nicer if you actually wrote if malloc equals null than if not malloc. I know this is less typing, but it's much less readable, and whoever comes along and reads your code later won't thank you for writing it like that. Anyway, let's go and have a look at an example using the null pointer. This is null.c, which is basically just void.c, but I've just added a few lines of code. The lines of code that test to see whether malloc actually returned a legal value or not. And if malloc did not return a legal value, in other words it returned null, then we're going to return null as well. And we're certainly not going to try and do this memory copy here. Because if we didn't bother to do this test, if we just assumed that malloc succeeded and malloc didn't succeed, then we would be trying to write that block of memory, in other words that many bytes of memory, onto that pointer which would be set to null. In other words, we'd be trying to write several bytes of memory to the 0 memory address, which would clearly crash our program. So now that this program returns null, we can actually test the return value of this program. In other words, we can write code like that. If the float array equals null, then the float failed, or the float malloc failed, or the duplication failed, or whatever you want to call it, some kind of error message. Otherwise, we can simply free it because it succeeded. Another way of doing that if-then-else type construct is to do it like this, using the conditional operator, question mark colon. That would do exactly the same thing, except of course this time it would do it for the integer rather than the float. And I don't know if you've ever seen this before, but you can actually write code that looks like this. Now there's no real else part involved here. I'm using the double ampersand. That basically tests to see whether that is true, and if it is true, it will test to see whether that is true. And if it's not true, if this first one is not true, then it simply does not do the second one. That is part of the definition of the double ampersand. Double ampersand, as you recall, tests to see whether two conditions are true. Now printf is not really a condition, but printf does actually return a value. It's just a value that we always ignore. It happens to return the number of characters that it writes out to the screen, so it might return a value of 10 or 20 or something, which you can treat as true if you really want to, even though it's kind of horrible to do so. So what we've got in front of us are two conditions, one that is a real condition and one that we're treating as a condition. Now the definition of double ampersand states that if the first one is false, then the second one is simply not even tested, because the value of the entire expression is definitely going to be false. Recall that for this entire expression to be true, then they have to both be true. Now if the first one's false, then they can't both be true, so the entire expression will evaluate to false, and we don't even run the second expression. It's a pretty ugly piece of code. I don't encourage you to write code that looks like that. I just wanted to show you that you can, to give you a greater understanding of the double ampersand sign. Anyway, null is pretty straightforward, just like void pointers are pretty straightforward, so that's pretty much the end of this module.